Okay, my dear. So today we are going to start a new chapter 22 electric field. And this chapter is not included in your midterm exam. So don't worry about this chapter. But anyhow, we have to finish 15 chapters for this semester. So still we have time. So I will keep on going regarding the other topics. I will not wait till the midterm finish because still we have 2 more weeks. So I will keep on going in our track. So today we are going to discuss chapter 22, electric field. And it is a continuation of the previous chapter. What we studied in previous chapter, my dear? What we studied in chapter number 21? What we
Charge.
studied in chapter number 21?
Coulomb's law.
Coulomb's law. Okay, if you want to write the Coulomb's law, what you need? The most important thing.
Charge.
We studied the concept of charges, positive charge and negative charge. And then by using these charges, we studied Coulomb's law. And by using these charges, we studied the concept of charge quantization. Am I right? So today, what we are going to do, we are going to study the concept of electric field. Have you ever heard this word electric field?
Magnetic. No.
Kinetic?
No, doctor.
For example, if you take a charge, for example, I take a positive charge or you take negative charge. One is positive, one is negative. If you put positive and negative, what will happen, my dear?
Attract.
It will attract, am I right?
Yes.
Yes.
Okay, now my question, how this charge will attract each other? Because we know this is positive, we know this is negative. But how the charge will recognize its neighboring charge? The charge, this is my question. Because we know this is positive, we know this is negative, so it immediately attract, am I right? But my question, how one charge will recognize the other charge and then it will attract? Because we said positive and positive, repel. We said negative and negative, repel. We say positive and negative, attract. Am I right? Okay, how this reaction, how these things happen? Why no answer?
Magnitude. No, I mean, it's like something to have plus and minus, red and
My dear,
blue.
because of the electric field. Because
Yeah.
the field tells you about the strength surrounding the magnetic field. For example, if you just take the positive
Yeah, I mean
charge, it
magnetic.
has some field, it has some field strength. So if you take a positive charge, the field strength, the field lines are going away. That means outward direction. If you take the negative charge, the field strength, inward direction. Clear? Understand?
Yes.
Yes.
So because of this field strength, the one charge will recognize the another charge and then it will attract and repel whatever it may be. Because we studied the concept of two charges, either two charges, sometimes it may be repel each other, sometimes it may attract each other. It's everything is because of the field strength. That means the strength surrounding the charge is called as a field strength. So based on this field strength only, the first charge will recognize the another charge. Now, what we are going to discuss in this topic, because in this topic also we are going to discuss some formula and we are going to discuss 5 formulas. Out of these 5 formulas, the first 3 formulas are very, very important. And we are going to solve 5 questions from this chapter by using the 3 formulas. So what are the topic today we are going to discuss? We are going to get some small introduction about this chapter, and then we are going to study the concept of electrical field, and we are going to study the concept of electrical field due to point charge, and then we studied the rules. If you want to study some rules about these electrical field lines, there are some 5 rules will be there. And then we are going to study the concept of dipole, and then if you place dipole in the electrical field, what will happen? So all this, for example, here I placed a 6 topic, but this chapter is very, very small. So before we go to this chapter, my dear, I would like to tell you about 4 important points. Just keep these 4 important points in your mind. Point number 1, point number 2, point number 3, and point number 4. Clear? Understand? If you take positive charge, if you take negative charge, the field lines will be always going outward direction in the positive charge. Clear? Understand? Understand, my dear?
Yes, doctor.
Yes, yes.
If you
Yes,
take the
yes.
negative charge, the field lines are inward direction. So
Inside.
calculating the electrical field is the vector quantity because it has both magnitude as well as direction. So positive charge means the field lines is going outward direction. Negative charge means it will be coming inward direction. This is your first point. If you recall these 5 points, 4 points, then this chapter is nothing. So please, my dear, that's what, before we go to the topic, I would like to remind all these things. Understand?
Yes.
The second point, we are going to study the concept of test charge. We are going to study the concept of test charge and point charge. What is the difference between this test charge and point charge? My dear, test charge should be indicated with the letter Q0 and the point charge should be indicated with Q1, Q2, Q3, whatever it may be. My dear, don't worry about this line because this line will always happen. So don't worry about this line. Sometimes I'm not feel that much comfortable about these lines. So what can I do? I think it's some issue with the hardware. I think so. So Q0, this is Q1 and Q2. Clear?
Clear.
Clear.
Okay. This test charge always small in size, and this point charge it's bigger in size. Clear? And then if you just see the test charge, your test charge is always positive, but your point charge sometimes it may be positive, sometimes it may be negative. Clear? And the test charge carries the value of 1. That means 1 coulomb. So if you take a test charge, the test charge is very small. If you take a point charge, the point charge is a little bit bigger than the test charge. And the test charge should be indicated with the letter Q0 and the point charge should be indicated with the letter Q0, Q1, Q2 or Q, whatever it may be. And if you just see the size, the test charge will be smaller and the size of the point charge will be greater than the test charge. And then this test charge is always positive, but the point charge, it may be either positive or it may be either negative. So this is your second point. Our third point, if you want to place, for example, I have a uniform magnetic field. So this is my magnetic field, which has the same value. Suppose if I have the uniform magnetic field, suppose I place positive charge in this magnetic field. Suppose I place positive charge in this magnetic field. What will happen? My dear, this is my uniform electrical field. Suppose if I place positive charge in this magnetic field, what will happen? The positive charge always moving in the direction of the electrical field. Suppose if you place the negative charge will be moving opposite to the direction of the electrical field. Keep this point. This point is very, very important. Understand, my dear?
Yes. Yes.
Okay. The last point, suppose if you have a point charge, suppose if you have a point charge Q1, Q2, Q3, whatever it may be. If you want to find the electrical field strength of this Q1, what you have to do, you have to test this point charge by using this test charge. So what you have to do, for example, my charge Q1 is positive. For example, my charge, because just before I told you, your point charge either it may be positive or either it may be negative. If you want to find the electrical field strength, field intensity of this point charge, what you have to do, every time you have to bring this test charge near to the point charge. So whenever you bring the test charge near to the point charge, sometimes it may be attract, sometimes it may be repel, because always your test charge is positive value. So please, my dear, keep these 4 points in your mind. Because why we bring this test charge near to the point charge? To find the direction of the electrical field. Okay, understand?
Could you
Yes,
please
yes,
read the last point?
I will
Number
repeat these 4 points again. Please listen carefully. I will repeat this 4 points again. The first point, if you take a positive charge or negative charge, the field lines for the positive charge always going outward direction. if you take a negative charge, the field lines are inward direction. The second point, we are going to study the concept of test charge and point charge. The test charge is small in magnitude, but the point charge is bigger in magnitude. The test charge always positive value, but the point charge, it may be positive charge or negative charge. Our third point, if you have the uniform electrical field line, if you put a positive charge in the field, what will happen? The positive charge moving in the direction of the electrical field, but if you put negative charge in the electrical field, what will happen? It will be moving opposite direction to the electrical field lines. This is our third point. And our last point, if you want to test the point charge, because just before we discussed our point charge, either it may be positive or negative, and it is having a bigger magnitude value. If you want to find the electrical field intensity of this point charge, every time you have to bring the test charge and bring near to the point charge. So whenever you bring the test charge near to the point charge, either it may be attract and repel, because our test charge is always positive and it has the value of unit. That means if you multiply with this test charge, your answer will not change. Clear?
Doctor,
Yes, my dear.
can you repeat the third one?
You have a electrical field lines. Okay, for example, I have a uniform electrical field. What is the meaning for uniform electrical field? If you measure the field strength each and every point in this place, it will be same. So if you have a uniform electrical field lines, you take positive charge and you put the positive charge in these electrical field lines. What will happen? The point charge, this positive charge will move in the direction of the electrical field. Clear? The force experienced by the positive charge is always in the direction of the electrical field. If you put a negative charge, it will always experience the force opposite to the direction of the electrical field. Understand?
Yes, Doctor.
Okay. So now we exactly going to the topic. So please listen carefully. Whatever the information I told you, it will be coming again and again. So it will be very easy to understand the concept. So this is our introduction. Actually, Michael Faraday gave the concept of this electrical field strength. So Michael Faraday is a very, very important, responsible for the study of this electrical field. So in physics, our space is completely surrounded by the charge, and this charge is surrounded by some field strength, which is called as electrical field. And then this electrical field exert the force on another electrical charge particle, because I told you an example how the positive get attracted with the negative. So the positive charge get attracted with the negative charge is because of the field lines, field strength, and this concept is given by Michael Faraday. Clear? And then let's come for this slide, and here I gave the picture of positive charge and negative charge. What I gave, you can see the electrical field lines. The electric field lines is moving outward direction, and here electric field lines are projecting inward direction. Am I right? And then here I told you already the same concept. Positive charge radially outward direction, negative charge radially inward direction. And now if you want to find the force experienced by the unit charge or force experienced by the point charge, so just before I told you, if you put a positive charge in the electrical field, it will be moving in the direction of the electrical field. So how you can find this force? If you just multiply the electrical field value and then the test charge or point charge. So you can use this formula for anything. If you want to use this formula for test charge, no issue. If you want to use the same formula for the point charge, it will give the answer. So from this formula, you can easily derive the expression. You can easily define the meaning of electrical field. What is the definition for electrical field? The definition for the electrical field is nothing but force per unit charge. So force divided by that unit charge. Unit charge is nothing but our test charge. So the general definition for the electrical field is nothing but force per unit charge is the definition for the electrical field. And the unit for this electrical field, either we can say Newton per coulomb or volt per meter. Clear, my dear? Clear?
Yes, doctor, clear.
Okay. Now, this is our first formula, my dear. Actually, this is the basic formula. So we are going to use this formula in some question, and also we are going to use this formula in some questions. So this formula gives you the information about the force experienced by the charge, and this formula how to calculate the electrical field for the test charge. Now here, if you just want to see this title, electrical field intensity due to point charge. Now what we are going to do, we are going to find the electrical field intensity of this point charge. You can see I put Q0 and Q. What is Q? Q is the point charge. Q0 is the test charge. So if you want to find the field strength of this point charge, I told you just before, you have to bring the test charge near to the point charge, and our test charge is always positive. And here the point charge, for example, the picture shows the positive charge. So positive get, what will happen? It will repel. So in which direction it will be repel? And that is the direction of the electrical field of this point charge. Clear, my dear?
Yes.
Clear? Okay.
Clear,
And the
yes.
formula for this concept is nothing but E, which is equal to 1 over 4 pi epsilon naught magnitude of the charge, point charge, divided by the distance between the point charge and the test charge. So now, my dear, this 1 over 4 pi is called as, what is this 1 over 4 pi? K. So K value is the constant. So I can write E, which is equal to K Q divided by R square. Clear? Clear, my dear? But how we got this formula? That explanation is given in this slide. Now you can see here, see this picture and please see the derivation in the left hand side. I have a positive charge. This is our point charge. This is our point charge. And what is this Q0? Q0 is the test charge. So now my positive charge, that means my point charge, has the electrical field lines, it's radially going outward direction. Now I want to find what is the field strength of this point charge. So what I'm going to do, I'm going to bring the test charge from some point towards this point charge. So when I just bring this point charge from distance to this point, what will happen? So the test charge is positive, my point charge here is positive. So what will happen? It will repel. So the most important thing, how much distance you place the test charge from the point charge, which is nothing but our R. So here the force experienced by the test charge, when you bring the test charge from some point towards this point charge, the force experienced by the test charge is given by the equation F, which is equal to E multiplied by Q0. This formula just before we studied. And then if you have two charges, what are the two charges we have here? Point charge as well as test charge. So two charges. So if you have two charges, you can easily apply the Coulomb's law for these two charges. Am I right? Am I right?
Yes. Yes, you're right.
So what is the Coulomb's law? F, which is equal to K, magnitude of this Q,
Q1.
magnitude of this Q0 over R square. Am I right?
Yes.
Am I right or not? Now you can see I am going to equate the equation 1 and this equation 2. When I just equate this 1 and 2, what will happen? My left hand side of the equation is exactly same. So I can write E Q0, which is equal to my Coulomb's law value. So Q, this is Q0. This is Q0 divided by R square. Now I can cancel this Q0 with Q0. So what is remaining, my dear? My E, which is equal to K magnitude of the point charge divided by R square. So how we got this formula? We got this formula with the help of the test charge. Clear? Clear, my dear? So we are going to use this formula actually we are going to solve 5 questions. And out of these 5 questions, most of the questions we are going to use this formula. So this is the first formula and it is one of the important formula in this chapter. Clear?
Yes, clear.
Okay. If you want to bring this Coulomb's law again, it is possible. So you can see, if you want to retain the Coulomb's law again, what you have to do? I am going to apply the formula for the electrical field. What is the formula for electrical field, my friend? Just before we studied, what is the formula for electrical field? Force per unit charge. Am I right?
Yes.
Am I right? You can take this formula, substitute here. If you substitute, what will happen? Your equation will be coming like this. and I want to find the Coulomb's law, because Coulomb's law is nothing but the electrostatic force. So I am going to keep this force here. I am going to move this Q naught to the right hand side of the numerator. So again, I can get the Coulomb's law here. Am I right?
Yes.
So you can bring the electrical field formula from the Coulomb's law, or you can move from the Coulomb's law to the electrical field. So everything is because of the test charge, because test charge carries the value of 1. So anything multiplied by 1 is give the same value. So here, if you want to test the point charge, every time you have to bring the test charge closer to the point charge, and it will be sometimes repel, it will be sometimes attract, and we can find the direction of the electrical field. Clear?
Yes, doctor.
Yes, Doctor.
Yes,
Okay.
doctor.
Now you can see here how many point charge I have here. How many point charge I have here? How many point charge I have here?
2. 2.
Okay. These 2 point charge, for example, suppose I can take this is a positive charge. So now what I'm going to do, I have to bring one test charge, and I have to bring from distance to this point. My test charge is right now here. For example, consider my test charge is here. When you bring the test charge from this point near to Q2, what will happen? Q2 is positive. Test charge is positive. What will happen? It will be repel, and this is the electrical field intensity direction of point charge Q2. Am I right?
Yes, it will be rebel
Yes.
to
Likewise,
the
if
same
you bring the
direction.
same test charge towards Q1, your Q1 is positive, your Q2 is your Q0 test charge is positive, it will be repel. So this will be the direction of the electrical field lines of Q1 charge. So now if you apply the vector adding, that means we know how to find the resultant vector. You already studied in physics 1 chapter 3. So you can find the resultant vector, and this is our resultant electrical field. Clear? Clear, my dear?
Clear. Yes, doctor.
Okay, now you can see here how many charges I have in this picture. 1, 2, 3, 4. And this is our point. Right now, I'm going to place the test charge at this point P. So if you want to find the direction of this Q1, bring the test charge. It will repel. Consider all the charges are positive. For example, if it is negative, it will be moving away. Clear? So if you bring the test charge from this point closer to Q1, what will happen? It will repel. Likewise, if you bring the test charge from point P to Q2, it will repel in this direction. And likewise, Q3, this will be the electrical field for the Q3. And if you bring the test charge to Q4, this will be the direction of the electrical field of Q4. Now, how many field strength you have here, my dear? I have 4 strength, 4 field strength. So I can find the resultant by applying the vector adding. So we already studied the combination of vector adding, how we have to add. Am I right? We already studied in physics 1. So this principle is called as superposition principle. We already studied in chapter number 21 how we have to add. For example, if you want to find the superposition principle of this picture, my electrical field, which is equal to the electrical field of Q1 is E1. The electrical field strength of Q2 is E2. The electrical field strength of Q3 is E3. So suppose if I have n number of charges, so I will get n number of electrical field. So when you just apply this rule, we know the formula for the electrical field. The formula for the electrical field is nothing but K Q over R square. So this is the formula. Suppose if you have n number of atoms, what you will get? My E, which is equal to K is the constant. So summation of Q n time over R n time. Clear? Clear, my dear?
Clear.
Yes, doctor.
Okay. And this slide gives you the information about the rules. Especially in this chapter, the most important formula is the electrical field due to point charge. But if you want to study more information about the electrical field lines, there may be some rules. You can see the picture. I gave five pictures in this first box. You can see I have a positive charge. My electrical field lines are projecting outward direction. Suppose if I have a negative charge, my field lines are projecting inward direction. Suppose my charge is very bigger, and you can see the number of electrical field lines. Whenever the charges become bigger and bigger, what will happen? Its electrical field lines also more in number. So you can see here, my charge Q2Q is nothing but it's a 2 coulombs of charge. So if you have a big charge, your electrical field lines will be more. Am I right? And the fourth diagram, your electrical field lines never cross each other, never intersect each other. It will be going closer to each other, but it will never touch each other. Clear, my dear? Understand? Clear?
Yes, yes, doctor.
Okay, now you can see this picture, my dear. You can see this first picture. Here I am just giving only 3 lines of these electrical field lines, only 3 lines. Just to see only 3 lines, I am just projecting, magnifying here. Here I just take 2 points, the point P and Q. And you can see from point P, my electrical field strength is greater. You can see the length of the arrow. It is very lengthy, am I right? And if you just see the length of the arrow in Q, it will be shorter. Why? Because whenever the lines are going closer to each other, its field strength will be more in this point. Whenever the lines are moving away from each other, the distance will be greater. When the distance will be greater, the electrical field strength will be getting weaker. That information is given here. So closer to the electrical field lines, the electrical field will be stronger. Whenever the lines will be separating from each other with more distance, what will happen? Your field strength, your electrical field strength will be weaker. Clear, my dear? Clear?
Yes, doctor.
Yes.
Yes.
Suppose my line is, it is like a curved structure. For example, this line is a curved structure. Am I right? How to find the direction of this curved structure? My dear, whenever you have the curved lines, the simple way how to find the direction of the electrical field, you can just draw a tangent line to the surface of the curved line. For example, this is my curved line. I just draw only the tangent line. So when you just draw the tangent line to the curved surface, that line indicates the direction of the electrical field. Clear? Clear, my dear?
Yes, doctor.
Yes, yes.
So these all 4 points, you can see the left hand side, these are all the main rules. Whenever you are just studying the concept of the electrical field lines, please remember all these 4 points. These 4 points are very, very important. Or you can just see the five pictures. Positive charge, field lines going outward direction. Negative charge, field lines coming inward direction. If the size of the charge will be more, you will get more field lines from the charge. And your electrical field lines never intersect each other. It will be going closer, but it will never touch each other. Near to the field lines, if the lines will be closer, your field strength at that point will be greater. If the lines will be moving far away from each other, then your field strength will be very, very weaker in that position. Suppose if you want to find the direction of the electrical field lines for the curved structure, you have to draw a tangent line to the field line, and that line gives you the direction of the electrical field. Clear?
Doctor,
Yes.
when I have 2 minus charge, I can add it
Okay.
together, right? It's equal to
Yes, you can.
2 Q, 2 minus Q, right? Minus
My dear,
2Q.
if you take one negative and one negative, it will not combine together. It will be ripple. It will be separated. But if you have only one charge having the value of 2 coulombs, then it is okay.
Okay, here how it's come 2Q?
My dear, 2Q means it is not a value. The size of the charge is bigger.
The size.
1 coulomb, 2 coulomb, 3 coulombs. Likewise, the value.
Okay, one column have 5 lines, right? And
My dear,
have
if you have smaller, my dear, for example, consider a weak man and a strong man. Who will have more power?
Weak man. Strong man. Strong man.
Strong man.
The strong one have more power, am I right? Likewise,
Yes.
if you have a weak charge and the strong charge, for example, if the charge carries the value of 1 coulomb, if the charge carries the value of 2 coulomb, which one is greater? The 2 coulomb charge is greater, am I right?
Yes, you're right.
So it will have more field lines. That's it.
Okay.
Clear? Okay.
Clear.
Now we come for the concept of electric dipole. From the word itself, you have the meaning. What is the meaning for di? It 2. Am I right? So if you have 2 charges, see this picture, my dear. My dear, see this picture. So define electric dipole. What is given here? This is the definition for electric dipole. What is the definition given here? An electric dipole consists of 2 charges Q equal in magnitude, opposite sign. You can see here the electric dipole consists of 2 charges equal in magnitude. That means the value remains the same, but what is the sign? One is positive, one is negative. And these two charges are separated with a distance 2d. So if you have two charges with opposite and equal sign, with the same magnitude and opposite sign, and if these two charges will be separated with some distance 2d, and that is called as electric dipole. And from this dipole, if you want to find the dipole moment, what you have to do, my dear, see this picture. You can just read these three lines. By just reading these three lines, you can easily frame the formula for the dipole moment. The dipole moment is the vector quantity. You can just read what is given here. Product of magnitude of any one of the charges. How many charges you have here? How many charges you have here?
Two charge.
Okay.
Two.
What is given here? Magnitude of any one of the charge. If you take the magnitude of this negative charge,
It will be
It will
positive.
be the same.
okay. If you take the magnitude of this positive charge,
Same. Positive.
same. So you have two charges. So electric dipole means it will have two charges with a different sign. One is positive, one is negative. So if you want to calculate the dipole moment out of these two charges, just pick only one charges and please take the magnitude of the charges. If you want to take a negative charge, no issue. If you want to take the positive charge, no issue. But you have to pick only one charge. Clear?
It will be same, right, doctor?
Yes, it will be same. But what is the definition? Still it is not completed. So product of magnitude of any one of the charge. So I will take one charge. So magnitude, the dipole moment is given by the letter P. I will take the magnitude of the negative charge, for example. Okay,
Okay.
multiply by the distance between the two charges. What is the distance between the two charges?
2D.
2D.
So 2d. And what is the meaning for product?
P.
What is the meaning for product? Have you studied the word product? Product is nothing but multiplication. So the formula for dipole moment is nothing but magnitude of negative is positive multiplied by the distance between the two charges, which is nothing but 2d, and this is the formula for dipole moment. Clear, my dear?
Clear, doctor.
Okay. Now this is our last slide of this chapter. So please, my dear, suppose I have a electrical field lines. My dear, now I need the answer from your side. Suppose I have a uniform electrical field lines. So you can see the blue color line. So I have three lines of uniform electrical field. Now what I am going to do, I am going to take this dipole, this electric dipole. What is electric dipole, my dear? What is electric dipole? What is electric dipole? This is our dipole. Am I right?
Yes.
I am going to take this dipole. I am going to put it in the electric field. So I have a uniform electrical field. I put the dipole here. My dear, what will happen? Because dipole means one is positive, one is negative. Am I right? Am I right or not?
Yes.
Yes.
When you put this positive and negative in the electrical field, what will happen? Positive will experience the force in the direction of the electrical field, and the negative will experience the force opposite to the direction of the electrical field. Am I right?
Yes, you are.
After sometimes what will happen? The torque effect will be created, and you already studied in chapter number 10 about the torque. Once the torque effect created, what will happen to the dipole? It will start rotation. Clear? Clear, my dear?
Clear, yes.
Okay, now what is the formula for torque? What is the formula for torque? You already studied in physics 1. What is the formula for torque?
R multiply
R F, R cross F, or RF sine theta. Am I right? You can write this
Yeah.
R cross F as RF sine theta. Am I right? Now, my dear, what is your R? R is the distance. Am I right? Now, what is the distance between these two dipole? This is our distance. Am I right?
2D.
So my
2D.
R is 2D. Very good. And what is your force? What is your force here?
Q multiply A.
Q multiplied by E multiplied by sine theta. Now I am going to ask another question. What is this Q multiplied by 2D? What is this Q
P.
multiplied by 2D? The Q multiplied by 2D is nothing but my electric dipole. Am I right? This is a dipole moment. Am I right or not?
Yes.
Q multiplied by
Yes.
2D is the dipole moment. So in this place, I can write PE sine theta. And what is PE sine theta? P sine theta is nothing but P cross E. Am I right? P is the dipole moment, E is the electrical field. So you have two formula for the torque. Either you can write P is sine theta or P cross E. P is the dipole moment, E is the electrical field vector. Clear, my dear?
Clear, doctor.
So how many formulas so far we studied, my dear? Could you please recall what is the formula for electrical field? What is the definition for electrical field? The definition for electrical field is nothing but force per
Charge.
unit charge. Am I right?
Yes, doctor.
Yes.
What is the formula for force experienced by the charge on the electrical field? Force experienced by the charge on the electrical field, F, which is equal to E multiplied by Q naught. Am I right?
Yes.
Okay. What is the formula for electric field due to point charge? Electrical field due to point charge, which is nothing but K Q magnitude over R square. Understand?
Yes, doctor.
Clear?
Yes.
And what is the formula for the torque of the dipole moment? The torque of the dipole moment is nothing but P cross E or
PE
PE
sine theta.
Sine theta.
sine theta. What is dipole moment? Dipole moment is nothing but magnitude of any one of the charge multiplied by the
Kg.
distance between the two charges. Am I right?
Yes.
That's it. This chapter is over. This chapter is over. Inshallah, next week I will teach you this problem, my dear. It's my kind request. This slide is already in the blackboard. Please, when you come for the next class, please just have a look of these 5 problems. Out of these 5 problems, and this problem is one of the important problems, and it is very lengthier also. Just to have a look of this, and when you just have a look, it will be you will get some idea. And when you come for the next class, I will teach you how to solve the problem. Because if you just see the answer of the second question, you can see how lengthier it is. It's very bigger, am I right? And in this question, you have to apply the superposition principle. You have to find the direction of the electrical field, and you have to find the x component. You have to find the y component, and finally, you have to give the answer in terms of unit vector notation. So out of these 5 problems, this question number 19 is a little bit bigger. So please try to take a print of the slide, have a look before you come for the class. Clear?
Okay, thank you, doctor.
Clear, doctor.
Okay, what's the time now?
2:40. 41.
Okay, I think today is enough. I think I finished because still we have 5 minutes. Am I right?
Yes.
What can I do? Shall I teach the problem, or we can just see next week, inshallah?
Next week.
Inshallah.
Next week.
Okay, next week, inshallah, we will see the problems because we have 2 periods. So I will teach you these 5 problems, inshallah, next week. Okay, my dear?
Okay, thank you,
Inshallah.
doctor.
Thank you, doctor.
Okay, my dear. My dear, please don't forget about your assignment.
Inshallah.
I am
Doctor.
asking the this assignment is very easiest one. Some questions are multiple choice questions, some knowledge question is also there. Take the preparation, my dear. Maybe your midterm exam will be like this. Clear?
Clear.
Okay.
Yes.
Thank you
Doctor,
very much.
midterm, it's offline.
Okay, my dear, listen carefully. The main thing I forgot. Yesterday we had a meeting and I forwarded your request regarding the backtracking. And the faculty, they actually, we take the voting for this backtracking and it is given to the chairman. Hopefully you will get a very good news, inshallah, but I don't know what is the result right now. But just please wait for some time, maybe before the final exam, before the midterm exam, you will know the clear picture. Okay?
Okay.
Okay.
Inshallah,
But listen,
online.
but
Offline.
listen, my dear, listen carefully. But listen carefully. I don't know whether they will accept this backtracking or not. We don't know the clear picture. But please ready for these both.
Okay.
We hope
Teacher,
that
Hopefully, inshallah. Let's we think in the positive side. Inshallah, if they agree to remove the backtracking, it will be good. But if they don't agree, anyhow, you can just get prepared for both. Okay?
teacher, you should but tracking. If I don't the answer, maybe I will know the grade.
My
The
dear,
mark.
listen. Which grade?
The mark for the question.
Which question?
If I don't know, I will skip it. Maybe I will lose the time.
My dear, that's what I said, my dear. Yesterday meeting, we requested this information to the chairman, and now chairman he got the voting from other faculties, and it will be forwarded to the higher department, higher authority. Okay. Hopefully
Okay.
by this weekend or next week we will get a clear picture. Understand?
Okay, understand. Thank you.
So let's be thinking the positive side. Inshallah, maybe they will consider. Or sometimes if they are not considered, well, we have to face everything. Okay. Clear,
Okay,
my
thank
dear?
you.
Okay, thank
Clear.
you.
Inshallah,
I
it will be
appreciate
easy.
your
Always think positive. Allah will make everything easy for you, inshallah.
thank you,
Okay.
doctor.
Okay, my
Inshallah.
dear. Okay. Inshallah, see you next week. Assalam.
See you.
Doctor,
Salam.
for the assignment.
Okay.
And the multiple choice, we have to choose only the right answer without.
My dear, listen carefully. Just take the print, give the answer in that paper. Just round out the correct answer. That will be quite enough for me.
Okay, only question 8, I think.
Only because I asked some question multiple choice, some questions you have to work out by your own handwriting. Okay, so take the print of the assignment and please circle the correct answer and give your answer for the descriptive type question. Okay, and then after you finish, scan the paper, convert it as a PDF file, send back through Blackboard. Understand, my dear?
Yes, doctor.
Okay,
Thank you.
doctor.
Okay, my dear. Assalamu alaikum.
Wa alaikum salam.